Thanks, dear. All right, chapter 5. Trigonometry identities. It's my most interesting chapter, I think, in trig. All right, let's look and see what is an identity. What is your identity, first of all? Mary, what's your identity? How do you know who you are?
By my passport.
By your passport, okay. Hannah, how do you know who you are?
Because who God says I am.
That's who God says you are, okay. Hattie, how do you know who you are?
I was going to say the Bible.
The Bible, good, yes. Heaven, Jesus, the Bible, that's good answers.
God.
Anna, how do you know who you are?
I was going to say like Anna Hattie, but also personality and different characteristics.
Different characteristics, right? You got a name, you have hair color, eye color, right? You have these really great fingerprints, right? So trig identities, read with me on page 312. An equation is an identity if the left side is equal to the right side for all values of the variable for which both sides are defined. Consider the equations below. So here, like we always do in algebra, we're given an equation. Both of these need to be defined on the other side of the equal sign. So we know for sure we have an equality going on there, right? So here I can subtract 3 because I'm going to combine some like terms, and I get x equals, it's a trig question, 9. Good. So the identity for x is the value can only be 9, and that's all we have is 9. So trig identities are identities that involve trig functions. You already know that the few basic trigonometric identities, the reciprocal and quotient identities below, follow directly from the definition of the sig trigonometric functions. First of all, I'm going to grab this little poster really quick, if I can reach it. It's one of my favorite posters made many years ago, and it's still a good one. Knocking everything else. Okay, oh, and it's really dusty. Okay, we're going to talk about all these different kinds of identities. Okay, so you already know reciprocal identities. Do you see them? Why are they called the reciprocal identities?
Because it's reversed. It's turned upside down.
They are, right? For the sine, it's 1 over the cosecant. For the cosine, it's 1 over the secant. For the tangent, it's 1 over cotangent. Cosecant is 1 over the sine. These are all reciprocals of each other, right? So you could replace them with the other one, what's on the other side of the equal sign. So this whole group is called reciprocal. That's the first ones. They have listed there reciprocal and quotient identities. So you're going to use those interchangeably when you're doing problems and they're asking you to prove this identity. Prove this is an identity. Okay? Let's try one. We've got first example 1. If the cosecant of theta is equal to 7 over 4, they say find the sine of theta. So what do you know relating cosecant and sine?
Reverse it.
Reverse it, right? We know that the cosecant of theta is equal to 1 over the sine of theta. Easy, right? So we look at this, we replace this with 1 over the sine of theta is equal to 7 over 4. How do we solve for the sine of theta?
Cross multiply.
We can cross multiply, okay? So when we do this, we get 4 equals 7 sine theta. We still haven't gotten all the way there, so we need to do what?
Divide by 7.
Divide by 7. So the sine of theta equals 4 over 7. Wouldn't it just been easier to turn that over?
Yeah.
Yes, but now you've seen it work through and understand that's what you're doing when you work it out like this. So we can replace this value with this value and then get sine of theta by working through the problem. Understand? That's how we're going to work some of these problems. Let's do another one. Cotangent of x equals 2 over 5 square roots of 5. And the sine of x equals, somebody read that to me.
Square root of 5 over 3.
Okay, and what does it say to find?
Cosine of x.
Find the cosine of x. Okay, I'm going to put that over there. Now our job is to find how is it related. Okay, so how can I get to this being given this information? What do we know about cotangent, first of all? Let me just point out
It's the opposite of tangent.
quotient identities. They're right here. Right? Because, well, again, we had cotangent is 1 over tangent, and tangent is 1 over cotangent, but I haven't yet related sine and cosine to them. So let's go back over here. Sine over cosine is tangent, and cosine over sine is cotangent. Good? Okay, let's plug in some information. If we know that cotangent is cosine of x over sine of x, right? And that's equal to 2. Then how can we use this information so that we can solve for cosine of x?
Cross multiply. Just kidding, you plug in the sign.
Plug in the information. Right, we're going to substitute the sine of x is now square root of 5 over 3. And the only thing we have unknown is this. Now we're going to cross multiply. Good. So we're going to cross multiply cosine of x. 5 square root of 5 equals 2 times square root of 5 over 3. Bear with me? Okay. So now I need to solve for the cosine, so I'm going to, well, here, let's simplify over here first real quick. 2 square root of 5 over 3. Let's divide by 5 square root of 5. What do we get? That look kind of ugly.
Well, when you'll flip over the bottom, so you'll end up crossing out the 2 square roots of 5. Yeah, so you'll have 2 over 15.
Okay, so then this is going to cross out?
Yeah.
And then 2 over 15. Okay, so let me just remind you over here, all I have left is cosine of x. And there is your answer.
Wouldn't you just use the inverse cosine and plug in 2 over 15, find out what x is?
They didn't ask for that, they asked for cosine of x.
Okay.
So it's easy. Eventually, yes, you will do that, and you'll have to get that answer. But for now, they ask you to solve for this. So you stop right there. So far, easy? Questions? Okay, let's keep going. We're going to add some more. We've got 2 sets already. We've got reciprocal and quotient. Now we're going to add the Pythagorean identities. Let me just point out these identities that are over here are just the manipulations of these 2. They'll come in handy at some point, and you might need to know with cosine and tangent that equals the sine. And you might need to know that cosine is equal to the sine times the cotangent. Okay? It's just a manipulation of that. Okay, so now we're going to look at Pythagorean. Oh, here's interesting. Sine squared plus cosine squared equals 1. That sounds a whole lot like Pythagorean theorem, doesn't it? Comes in handy. And then we have tangent squared plus 1. Where'd it go? Tangent squared plus 1 is equal to secant squared of theta. A lot of squareds in there. How do you handle those? On your calculator, it's the same as secant times secant. That's the secant squared. Okay, let's look and see how we're going to use them. These are called Pythagorean. Look at example 2. Somebody read it out loud while I erase.
Read what out loud?
Example 2.
Tan of theta equals -8, and sine of theta is greater than 0. Find sine of theta and cosine.
Wow, that sounds like a whole lot of something. Sine of theta is greater than 0. Then find the sine of theta and the cosine of theta. Okay, so our goal is to find the sine of theta is equal to what? And the cosine of theta is equal to what? Well, what do we know about this?
Tangent squared plus 1 equals sine of theta.
Tangent squared plus 1 is equal to what?
Is it sine?
Secant. Okay, what do we know about that information? We got any information on that we can do with that? In the example they show here that they use tangent squared theta plus 1 equals secant squared theta. They know that the tangent squared is equal to -8. Let me just write that down. went to secant squared? What are they shooting for here? To use the Pythagorean identity for what? To get to what? Cosine, right? Because cosine is what's related there. Why don't they just say, okay, well, tangent is just sine over cosine? Because all we know about sine right now is that it's greater than 0. So we're not really for sure how to get that. But if we can relate only one thing, so we can eliminate having 2 unknowns, right? So let's follow what they did here. So they plugged in -8 here. -8 squared plus 1 equals secant squared. And then they got -8 squared is 64 plus 1, which is 65. Then they come at, finish it out to be secant is equal to square root both sides. And we get the square root of 65, right? Don't forget it can be plus or minus. You're taking the square root on that side. We know on this side we can replace secant, sorry for that, with 1 over cosine of theta. How do you get to cosine? You can cross multiply, or you know that you can flip it over, right? So here we get 1 over the square root of 65, plus or minus, equals the cosine of theta. Mathematicians don't like it when you leave that in the bottom, so we need to rationalize the denominator. We get square root of 65 over 65 is equal to the cosine of theta. So far, so good? Okay. Now it says since tangent, now we go back to the one I mentioned first, since the tangent of theta is sine over cosine, can't we use this information to now solve for the sine? Yes, we can. So let's plug it in. Let's go over here and say tangent of theta is equal to sine theta over cosine theta. I'm going to plug in everything that we know. Tangent of theta is -8. Cosine of theta is, oops, hang on. Put sine of theta on top, and this is plus or minus square root of 65 over 65. Good. Cross multiply. Everybody good with that?
Wait, why would you cross multiply when you can just multiply? Just multiply the bottom part toward the other side.
Comes out exactly the same. If they cross multiply, you can just do it. Okay, I'm going to multiply this bottom part. Yep. Oops. That's supposed to be a plus there. So what do you come up with here? On this side, sine of theta. What do you get on this side? Well, you know what the negative gives me? Plus or minus 8 squared is 65 over 65. Yes?
Yeah.
Yes. Okay. They have on the right hand side, let's look at that really quick. I want you to look at the blue note where it says tangent of theta is equal to -8 and the cosine of theta is equal to negative square root of 65 over 65. Why? Look at the paragraph right above it. Since tangent of theta is equal to sine theta over cosine theta is negative, and sine theta is positive, right? Sine theta. So let's look at our quadrants one time. Talk about, in this one, everything's positive, right? Sine and cosine. In quadrant 2, what are the signs here?
Positive, negative. Negative, positive.
Negative, positive. Quadrant 3,
Negative, negative.
okay. Quadrant 4,
Positive, negative.
okay. So in the quadrant they're talking about, if tangent is negative, that means that it's either one of these two quadrants for the tangent. If sine theta is greater than 0, well, we don't see anywhere, right? But knowing that it's one of these two quadrants, right? How do they state it? Sine theta is positive, right? Greater than 0.
So it's the second quadrant.
Mm-hmm. And cosine theta must be negative, since tangent is negative. Follow? So that makes this, where'd it go?
Your answer's over on the right side.
Negative.
Negative.
This to be negative only.
Yeah.
So once we put negative in here, we don't have that positive aspect anymore. Negative and negative gives you only positive for the sine of theta. This one's positive, this one becomes only negative. So you gotta work through your quadrants when you're talking about tangent and you've got a negative involved. Okay, questions about this one? No? Let's do one without them working it out for us. Let's look at 2A, guided practice. I'm gonna make the quadrants up there. Oops, I just erased one. Okay, what is let me read the problem.
2A.
Yes.
The cosecant theta and tangent theta. Cotangent theta equals -3, while the cosine of theta is less than 0.
What's the last part? Okay, so let's talk about this scenario first, right? We're wanting to find the cosecant and the tangent. If cotangent is negative, which quadrants are we talking about?
Wait, what?
Cotangent is negative. What is cotangent equal to?
Tangent.
Okay, so if this is negative, we know
2
it
or
has to be
4.
in which one of these quadrants?
2 or 4.
2 or 4, right? So far we know this. Then they give us another stipulation that it has to be less than 0. Which one of these?
2.
Yes. So we know that it's only in that quadrant. So far so good. Very good. I'll follow that one. So now that we have this information, we can go and say, okay, well, we need to get this. What is this related to?
Cosine. 1 over
1 over
secant. Sine. Sine.
sine, okay? So 1 over sine theta. And then tangent is sine theta over cosine theta. All right, so we need to get this information, and we need to get this information. How can we get this one first? We know cotangent is -3. How can we go from cotangent to tangent?
Flip it.
Flip it, right? These are related, they are reciprocal. So I'm going to flip this over. I'm going to get tangent of theta is equal to 1 over 3. Positive or negative?
Negative.
It is still negative. Everybody with me so far?
Try.
Okay. Now let's go through. We've got this one. Conveniently located. Which one of these is going to have a negative sign, the 1 or the 3? Look back at your quadrant.
1.
The
3.
3. So I'm going to just move this down here, put that negative, that plus. So what is the sign of theta? 1. So what is our cosecant of theta equal?
1.
If we know this, then we get this equals 1. Cosecant of theta equals 1.
Let's see one of those things for a second. Okay, say them quickly.
Okay. So we've got this one's 1, and this one's 1/3. Let me check my answers. Tangent is correct. They got cosecant equals square root of 10. What did I do wrong? Cotangent is equal to -3. Let me think about this just a minute. We missed something somewhere. They're saying the cosecant of theta is equal to square root of 10. What's wrong? Huh?
What's wrong?
Pause for emphasis. over the sine. Let's draw it. Okay, so we've proven that this is our theta, right? We've proven so far that the cotangent, which is cosine over sine, is -3. So we know this is -3. And the sine would be 1. What would this value here be? So why is the cosecant? Cosecant is 1 over the sine. The sine is 1 over the square root of 10, right? So let's go back and look at this. So the sine of theta is 1 over the square root of 10. So 1, being this 1, sine of theta is 1 over the square root of 10 based on my triangle, not just 1. Then this becomes what? Square root of 10. Missed that the first time. So one of the things you might be able to do that would help to emphasize is to draw your triangle. Once you figure out what quadrant you're talking about theta is in, just go ahead and draw your triangle and put the values that you're learning as you go through it. Use Pythagorean theorem and come back and figure out the side you don't have, whatever side you haven't found that information about. Let's do another one. Let's do 2b. Questions about what's here before I erase? No? Okay. Okay, let's see. Somebody read me 2b.
Cotangent of x and secant x. You know the sine of x equals 1 over 6, and the cosine of x is greater than 0.
Okay, so let's talk about what this might be. Where will this, which quadrant? Let me erase the last problem. What quadrant are we talking about here? What's the possibilities? We know that the y has to be positive, right? Where's y positive?
Y is y. Just kidding.
Right? And we know that the cosine has to be
Positive.
positive. So this is the only one. So let's draw our theta in here. And let's say what we know. We know that the sine of theta, or x, right? And x in this case, is opposite over hypotenuse. What is this side? I don't know. 1 squared plus x squared equals 6 squared.
35. Square root of 35.
Mm-hmm. Okay, so put square root of 35. Now they're asking us cotangent of x. What does the cotangent of x identify as? Look at your identities.
Cosine over sine.
It is cosine over sine. Okay? Okay, what is your secant identity?
1 over cosine.
1 over cosine of x. Okay, let's plug in what we know. We know all the values of the triangle now. Let's use it. Let's do secant first. So secant of x is equal to 1 over, what's the cosine? Cosine of x right here. Basic trig identity, cosine is what? Ka. So it's square root of 35 over 6. Can't leave it in the bottom like this, so we're going to flip it, bring it up. This equals, multiply by 1. Rationalize the denominator. This equals 6 square roots of 35 over 35. Okay, that's a good answer for that. Let me check it, make sure. Perfect, we did good. Okay, what about cotangent? Let me erase this. Well, I should I put in for the cotangent of x? What's the cosine again?
6 square root of 35 over 35.
Okay, we came out with secant being that.
I mean, flip it over.
Yes.
Square root of 35 over 6.
Square root of 35 over 6. Okay, what's the sign?
1 over 6.
Sign is 1 over 6.
So the 6 will cancel each other out, so you'll just have square root of 35.
Okay. Good? Okay, following? Okay, so far we have 3 sets. Let's review. Reciprocal, quotient, and Pythagorean. These are all identities you can use based on the information given in the problems to work with some what problems we'll have tonight. Okay? One more section. Cofunction identities. This is another set of basic trigonometric identities involve cofunctions. What do you think cofunctions would be?
Cofunctions.
Cofunctions. Cofunctions?
Cofunctions.
Cofunctions. I don't know. Cofunctions. What do you think that is?
Function that helps the other one.
They work together, kind of like cooperatives, right? A trigonometric function f is a cofunction of another trigonometric function g if f of alpha is equal to g of beta. They have the same values. Do you know any trig functions that work together like that? You do. Let me write down some. These are not on my fold, my nice little folder here. The sine of theta is equal to the cosine of what? What's the chart say?
Pi over 2 minus theta.
That's interesting. Let's write down one that we know and show how this works, okay? How about the sine of 30 is equal to the cosine of pi over 2 minus 30. Let's write it in radians. Pi over 6. Okay? Let's go back and look at this. Erase this right now. Let's just remember, what is the sine of 30 in the unit circle? What's the sine of 30? What's across from the 30?
60.
Over here is 2x. This one is x. This one is
Square root of 2 over 2. 3.
x square root of 3. If we know this is 1, right, for the unit circle, across from the 30 is half. Across from the 60, which is up here, is
Square root of 2 over 3.
square root of 3 over 2. You confused me, didn't you? Yeah. So let's look and see. What is the sine of 30 degrees? The sine is opposite over hypotenuse.
1/2.
1/2. Okay. What is the cosine of 90 degrees minus 30 degrees? 60 degrees, right? I'm going to put 60 degrees here so you can see that answer. From 60 degrees, if you want to use this one, the cosine is adjacent over hypotenuse, which is 1/2 over 1. These two have the same value. These are called cofunctions. Make sense? So you can use those interchangeably. It really helps to work out the identities with those. So you can see the other ones that are listed. Cosine of theta is equal to sine of pi over 2 minus theta. The tangent of theta is equal to cotangent of pi over 2 minus theta. Cotangent is equal to tangent of pi over 2 minus theta. The pi over 2 seems to be something in common there. Secant is equal to cosecant of pi over 2 minus theta. And cosecant of theta is equal to secant of pi over 2 minus theta. So everything, if you subtract it, whatever you're given for one function, then it's cofunction. You can subtract from 90 degrees and use that angle. And they will have the same values. okay? It says you've already seen that each of these basic trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, is either odd or even. Using the unit circle, you can show that the following statements are true. The sine of alpha is equal to y, and the cosine of alpha is equal to x. We've already talked about that. And the sine of negative alpha equals negative y, and the cosine of negative alpha equals negative x. Sorry, positive x in that case. Recall from lesson 1-2 that a function f is even for every x in the domain of f of negative x equal to f of x. And odd if for every x in the domain of f, if f of negative x is equal to negative f of x. But think back really hard, chapter 1, section 2. If you don't remember, go back and read over it. I bet it'll ring a bell. These relationships lead to the following odd and even identities. Do we have those? Odd and even identities. Ooh, some other ones they've added this year. So the sine of negative theta equals the negative sine of theta. They're the same. You can interchange them, and they will come in handy. The cosecant of negative theta is equal to the negative cosecant of theta. The cosine of negative theta is equal to the cosine of theta. Ooh, that sounds really strange. Think about that for a minute. The cosine of negative theta. Let's review that one for just a minute. If we were to put here, we already have a triangle up here. They're saying that these two are the same value. Let's prove it, okay? What's the cosine of 30 here? Adjacent?
3 over 2.
Yep, square root of 3 over 2. Okay, if we have a negative 30 degrees, I'm going to write this a little smaller up here. This way, this is the 30, across from that's 1/2. That will be square root of 3 over 2.
It's still the same.
It is the same. Square root of 3 over 2. This information came from your ratios of sides for a 30, 60, 90 on the unit circle, okay? So these values here you can use interchangeably to help you work through identities. Look at example 3. If tangent of theta is equal to tangent of theta is equal to what?
1.28. Find the cotangent of theta minus pi over 2.
Minus pi over 2?
Yeah.
Like that?
Yeah.
Okay. So what do we know? Any thoughts?
Well, that's reversed from the cofunction identities.
Okay. So how can we fix this to where it matches the cofunction identities?
Put negative in front of the cotangent.
Okay. We
Switch
can
it.
substitute. Let me go over here. Theta minus pi over 2. Can we multiply by -1 here? Which would give you pi over -1 out here. Or let's say I'm not going to multiply by -1. I'm going to factor a -1 out. Okay? So I pull my -1 out front. That leaves me positive pi over 2 minus theta. Does that now substitute in there very well? Easily, correct? Now I have my signs correct on my terms here. So let's go ahead and write that up there. Cotangent of -1 times pi over 2 minus theta. So far, so good? Right, follow? Okay. So now that we have the pi over 2 minus theta, we know what equals what? What does this equal?
1.28.
This equals tangent of theta, right? Or the minus the tangent of theta. See where I substituted this value? Into there. That came from which type of identities?
Cofunction.
Odd and even identities. You see it? This was from cofunctions, right? We switched from here to here to get to the cofunction identities. And
Yeah,
then
but aren't you using the cofunction identity to state that the cotangent?
we're using it.
Yeah.
We are looking here to see where to go.
You use the odd even to switch those.
To switch them, that's correct.
So you used odd even first, and now you're using cofunction.
Correct. I said it backwards, I'm sorry. So we're using odd even first, and now we're going to cofunction, so we can switch it to the tangents. What are we looking for? We have this information. We're trying to get to this, okay? So then we plug it in and we get that this is the negative 1.28, and this is our answer. Okay? Want to do another one? Just like that? Sure. That was a good practice, right? Okay, let's erase this one. Okay, got to practice 3.
If sine of x equals negative 0.37, find cosine of x minus pi over 2.
Okay, so first thing we're going to do is use which type of identities?
Odd even.
Odd even. What are we going to do with it?
Take a negative 1 out front.
Yep, we're going to take the negative 1 out front. What's left in here?
Pi over 2 minus x.
Okay, now what do we know about this related to this?
Cosine is 1 over sine.
Cosine is,
Or it's also cosine of theta equals sine.
well, hey, there you go. What is it? Cosine of theta equals? Let's look and see where we have the sine of theta equals. So our
You do basically what you did in the last one, you just make it negative sine.
right? I'm gonna bring that negative sign out front of here. Hang on, draw a line, -1 cosine of pi over 2 minus x. Yes, you can do that. You can bring the negative out of there, out front. Doesn't change anything, it's the same. So now I can substitute this value and give this sign. So this right here is equal to the sign. I change it to theta, it should be x. Now we can put in this value here. And we get 0.37. Okay? Questions? Alright, so it's homework. 5 ones, 1 through 21 odd. Make sure I got the right one. We're through example number 3.
21 too.
1 through 21 odd, yes. 1 through 21. Okay.